Hi there, welcome back to this channel. Now, if you have been having struggles with the concept of harmonics and overtone, I promise you that in this video, I'm going to do justice to the topic and you are going to learn it. You are just in the right place and you have selected the right video to watch. And by the end of this video, by the grace of God, you are on your way to smashing any question that comes out from harmonics and overtone under sound waves. All right, let's get into it. Now, in order to understand concept of harmonics and overtone, you have to understand what we call vibrations and musical instruments. So first, understand that musical instruments are grouped into three, and they are the string instrument or stringed instruments. We have the wind instrument or pipes, and we have the percussion instrument. Now, in our analysis, in our concept of analysis of harmonics and overtone, we only analyze both of this. Do you understand? Not percussion. All right, so string and wind instruments. Now, how do we analyze strings and wind instruments? Before we analyze them, we have to understand first the types of instruments that are string, and those are the guitar, the violin, the viola, keyboard, etc. Then the wind instrument, trumpet, sax, trombone, flute, etc. All of those are wind instruments. Now, how do you analyze both of them? Now, if I played a trumpet, you are very likely to be able to differentiate it from when I play keyboard. For example, that sound you can hear, that is a saxophone. Do you understand now? So the reason why we're able to differentiate between those sounds is because of what we call overtones, the set of overtones that a particular musical instrument can produce. All right. Now, what are overtones? Before we understand overtones, let's talk about harmonics first. Harmonics are integer multiples of the fundamental frequency. So here is the fundamental frequency of a particular instrument, and multiples of it, integer multiples of it. That set is called harmonics, set of harmonics. Is that okay? It's not just one we call harmonics, there's a set. You understand? Then the overtones are a set of frequencies that are greater than the fundamental frequency. So what then is the fundamental frequency? Now, the fundamental frequency is the lowest frequency. So fundamental frequency is the lowest frequency that a musical instrument produces. Is that okay? The lowest possible frequency or the lowest possible mode of vibration. Do you get it? Then the F sub 1, which is the, harmonics rather. The harmonics are a set of frequencies including the fundamental frequency. So once we go from fundamental frequency and we are going in that series like that, you see the set of frequencies that a string or the wind instrument can produce. So that set that includes the fundamental frequency is called the harmonics of that instrument. Then overtones, so we say they are integer multiples of F naught. If this all confuses you, you should just follow me. You are going to understand why we call it integer multiples, because you are going to see that all the set of frequencies we will create, they can be gotten from the fundamental frequency by just multiplying that fundamental frequency by a number. So that we call it by a particular integer. So that's why we call it. We call them integer multiples. Do you get it now? Then the overtones are higher frequencies than the fundamental frequency. Any frequency higher than fundamental frequency is an overtone. So set of overtones are all the set of frequencies that are higher than fundamental frequency. So what that says is that what that means is if F sub 0 is the fundamental frequency, then F sub 1 and above will be what? Overtones. Does that make sense? So if I say create me a set of harmonics. Now a set of harmonics we start with the fundamental frequency, then the second harmonics, then the third harmonics, then the fourth harmonics. See what confuses students? So they think is by the numbering. F sub 0, fundamental frequency, first harmonic, first fundamental frequency or first harmonic. Is that okay? Second harmonic, third harmonic, fourth harmonic. So the fundamental frequency is the first harmonic. Then overtones. The set of overtones. In the fundamental frequency, we say overtones are higher frequencies, right? So in the fundamental frequency, there is no overtone. The first overtone occurs in the second harmonic. Is that correct? So second harmonic, first overtone. Is that okay? Third harmonic, second overtone. Fourth harmonic, third overtone. Is it clear? All right. So now, let's create the set of vibrations for a string instrument. We're going to start with the string and then we graduate to the wind instrument. So for a string instrument, a string is usually attached between two fixed points, you know. So by the time now the lowest frequency that this string can produce is the frequency it will produce if I pluck it by just fixing it when I fix it at these two ends. So if I pluck it from here, it is fixed at these two ends. These two ends of fixing are called the nodes. Node are the points on a wave of minimum or no displacement at all. Is that okay? So, and I said you can use no displacement to remember it, albeit it is not the origin of the word, but you can just use that to remember no displacement. No, no. D, displacement, no displacement. So point of no displacement or the fixed point at the node, and the point of maximum displacement is the antinode. Is that okay? The antinode. Now, if I plug this string to send down a vibration like this and return the vibration this way. So if this happens, we're going to have a node, and the point of maximum displacement here is going to call what? An antinode. Okay? So this is the lowest kind of vibration that can occur here. This is the lowest form of vibration. So in this case, this string or this string has a particular length, isn't it? That's the length. So, but we analyze based on the length. So let's see the wavelength that covered this entire length. Now, how many wavelengths is this? Now, this is the trick. Whenever you want to analyze wavelength, and I know that's where confused students, what you do is this: you read from an antinode to a node, or a node to an antinode, because the wavelength between a node and antinode is a quarter wavelength. So once you know this fundamental concept, you're able to analyze any wave at all, any waveform, even for a waveform like this. For example, all you need to do is point on the equilibrium line and node. Is that okay? So this will be node, maximum displacement, antinode. Node and antinode and node and antinode and node and antinode and node. Do you get it? Yeah, you cannot destroy my vibe. Alright, so if I said how many wavelengths are here, some students already know how to do it. These are actually two wavelengths. 1, 2. That's 2 lambda, right? But if you don't know how to do it, just first analyze it this way that I've said. Then, of course, these are not nodes and antinodes because this could be for light wave, this could be for, you understand? So, but this will just help you to analyze it. So, between a node and an antinode, we said what? A quarter wavelength, right? So let's see. Quarter. So let's count how many quarters we have. 1, 2, 3, 4, 5, 6, 7, 8. So that will be 8 quarters. 8 times of quarter wavelength. So 4 here 1, 4 here 2. So what do we have? 2 lambda. You see that? Right. So you don't need to stress yourself about looking at it in one way. Just draw your node and antinode and node and antinode and node and antinode and node. All right. So the next thing you now do is, so let's draw a node and antinode. So node and antinode here, 1 quarter plus another 1 quarter. From here to here, a quarter from here to here. Every distance between node and antinode is a quarter. Just take it that way. So 2 quarters will be what? Half. Does that make sense? So here we therefore have that lambda will be equal to 12. We always make lambda the subject formula because we don't analyze with respect to the wavelength that is sent on the string, but with the length of the string. So once you know that you are dealing with the fundamental frequency, remembering that the frequency of a wave is V over lambda, you just say fundamental frequency will be equal to V over lambda is now 12 for this guy, so 2 over V over 12. Is that clear? All right. Now let's do the next set. Now the second set is this, that now the fundamental frequency was created by not fixing any other point in this thing and just plucking directly. Now here I fixed it at these 2 points, but then again we want to fix somewhere in the middle here. If we fix that and we send the vibration, we plug this string, it's going to send the vibration like this, down like this, something like this, and return it through that same point. Is that okay? So if the vibration is sent like this, then we want to analyze this thing. This thing has a length from here to here. So let's analyze how many wavelengths are there. You have a no, down, nanti, no, down, no, down, nanti, no, down, no, down. Now, if you don't sing the song, you might not really get it. So try and sing the song. All right. So between here, how many wavelengths, how many quarters do we have? Let's see. The entire length consists of 1, 2, 3, 4 quarters. So that will be 4-quarter wavelength. Is that okay? So that what? L equals lambda, or lambda is equal to L. Then we substitute in our equation again. But this time it's no longer F naught, because we have increased the set of vibration. So by 1, so that becomes the second harmonic. But now this is a higher harmonic, a higher vibration than the fundamental vibration. So that becomes what? The first overtone. Overtones are what? Higher than F sub naught, right? So this will be our first overtone. So this now becomes V over, now lambda here is L, so we have V over L. As simple and short as that. Now let's do number 3, this is number 2. Now in number 3, we have the same guy. Now this time, we want to fix it at 2 points. We fix it at this point and this point. So we set our vibration, it goes like this, and like this. Then it returns it this way. So we analyze the same way. We analyze it the same way. We have no, down, nanti, no, down, no, down, nanti, no, down, no, down, nanti, no, down, no. Keep in mind, you must sing the song. If you don't sing the song, you might not just really get it. All right. Well, don't go to the comment section and I'll say that I did not sing the song and I got it. All right. Okay, so we have the entire length of this string covers how many wavelengths we have. How many quarters? 1, 2, 3, 4, 5, 6 quarters. That will be 6 quarters wavelength. 2 here, 2 here, 3. And length will be equal to 3 lambda over 2. Let's make lambda subject. That becomes 2L over 3. Does that make sense? Then we'll now substitute it into our equation of frequency, which is always V over lambda. Lambda now being this 2L over 3. So F sub 2 equals what? 3V over 2L. Why is the F sub 2? Because it is one more step higher than the first initial harmonic, right? So this will be the third harmonic, but what? Second overtone. All right. So now you're going to pause the video and create the next harmonic for me. So this time you know, of course, that you're going to hold it, fix it at how many points? 3 points. Is that okay? So fix it at 3 points and let me know your answer in the comment section. Of course, I'm going to do it now. All right, so let me now review the secrets to you. We are fixing at how many points? 1, 2, 3. Right? So when we send a vibration like this, the vibration will go chicka like this. Like this, like this, like this, like this. Return like this, like this, like this. If one is not returning, then maybe you didn't send it well. Alright, let's go. Then we now sing our song, right? Then we go, no, dan, nanti, no, dan, 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 no. You get it? Alright, then we now have how many, in the entire length, how many wavelengths do we have? Just go 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. Are we sure? 8 quarters. So it means that those, okay, 8 quarters of wavelength. That will be 1, 2, okay. So here 1, here 2. So L will be equal to what? 2 lambda. So that lambda becomes what? L over 2. Am I correct? Okay. It looks strange, like I've not done it before. Okay, so the frequency, which is the next frequency, that's the 4th harmonic, right? That will be the 4th harmonic. We equal to, now you see the way I'll gather all of them together and you see it. V over L over 2. What does this become? F sub 3 equals what? 2V over L. I've told you, whenever you are dividing by a fraction, just take the denominator up and over that that numerator. So that's the way we did this. And that's what we did here too. We just took this guy up. But we are dividing a fraction, for example, by a number. Simply merge them. 2 over 3 divided by 4, that becomes 2 over 3 times 4. All right. Okay, so now we are going to stop here and go to wind. Before we go to wind, let me show you the set of harmonics now. So the set of harmonics that we have created now are the first harmonic fundamental frequency, that's what? V over 2L. Second harmonic, V over L. Third harmonic, 3V over 2L. Fourth harmonic, 2V over L. Now, what does this look like to you? Does this not look like, when we said second harmonic, does this not look like we are saying 2 times F sub naught? So that F naught will be 1 times F naught. Let's see. 2 times F naught is what? 2 times V over 2L. Does not look like it? Third harmonic is what? It looks like 3 times F naught. Because 3 times this will give us what? 3V over 12. For this one, fourth harmonic, 4 times F naught. Use it now. So that's what we call harmonics integer multiples of the fundamental frequency. We are just multiplying by the integer. So our first harmonic is 1 F naught, second harmonic is 2 F naught, 3 F naught, blah blah blah. Do you get it now? All right. Now let's now go to wind instrument. Yeah, wind instrument. Somebody say wind instrument. All right, let's go. Wind instrument or pipes. There are 2 types. Is either the pipe is open or the pipe is closed. Now, if the pipe is opened, that the pipe is closed does not mean it's closed at both ends, because there has to be a place that is open for us to send in vibration, right? So when we say closed, we mean open at one end, closed at the other end. When we say open, which is what we're studying first, for pipes, open, we have something like this. It's open at both ends. Is that okay? So we send in our vibration. The lowest kind of vibration we can see here is this. Is that okay? This is the lowest vibration that can happen here. Now, this pipe also has a length. From here to here is a length. You know, we could slant it over like this, It's the same. Do you understand? As in, we could, this thing now, by sending my vibration still to go something like this and something like this. Is that okay? So this thing still has length, so it's the same. I'm really trying to stand it. So this is length. All right. Now, how many wavelengths are here? So just the same thing, the maximum displacement. Antinode, anode, and antinode, that's all. So here we have 1, 2, that's 2 quarters. Does that make sense? So that becomes here 1, here 2. L equal to lambda over 2. So that lambda will be equal to 2L. We've seen something like this before. It's looking like it. Okay, let's see. So it means that F sub naught for a pipe that is open at both ends is what? V over 2L. Just like this guy. Let's see if it will change in the next case. Let's see what will change. Now the next, so this first harmonic. The second harmonic will be this. We send down a vibration in this pipe. With something like this is what we get. No. All right, something like this, right? Okay, so in this case, what do we do again? We know it has a length like this, a length like this, and what do we have? We have antinode and node and antinode and node and antinode and node. Okay, there's no node. All right, so we're going like, so notice that with open pipes, we always end up with what? Antinode. Does that make sense? Okay, so in this length, let's see, 1, 2. So this is, 1, 2, 3, 4, right? So the entire length is what? 4 quarters, right? So 4 quarters is L equals lambda. So lambda equals L. it looks like this again. The second one. Okay, it means that, so then the F1 will become what? V over L. So it means that the set of vibrations that we set in an open pipe is equal to the one we set in a string. Does that make sense? If you look at it for string, this is why it's like that. For string, we always fix two ends. So node and node. It always then starts with node and end with node. This one, we always open two ends. Antinode and antinode. Is that okay? So that's why the set of vibration is exactly equal. So the set of harmonics and the set of overtones for string and open pipes are the same. All right, let's see closed pipes. Closed pipes. Okay. You know what I went to check? That was recorded. All right. The next one is, you know, the devil is crazy. Yeah, happened I have not pressed play. No, I'm not. You know, I can go and kill the devil if that happened. And the devil call. Let's set it today. Okay, let's go. Then for winds, closed winds now. Closed pipes, rather. Now, for closed pipes, so the first vibration, this is a closed pipe. The first level of vibration we can send, that we can have, rather, create is something that looks like this. Something that looks like this, everybody. Something that looks like this. Now, this guy now, I'm gonna have, this guy has a length, yeah? The pipe will have a length. Then so this point is what? Node down, antinode, that's all. Alright, so the entire length is only what? A quarter wavelength. Does that make sense? So lambda will be equal to what? 4L, okay? So F sub naught for a closed pipe, the lowest frequency is going to be what? V over 4L. Okay. Then number 2 case, what if we sent in a vibration that goes like this? In this case, we're going to have node and antinode and node. Just look at it like this is the maximum displacement in case it's confusing you. Like this is the, think of median line. So node and antinode and node and antinode. Is that clear? Okay. If that is the case, then we have 1, 2, 3. So the entire length is actually equal to 3 times quarter wavelength, right? 3 quarters. So L equal to 3 lambda over 4. So that lambda will be equal to what? 4L over 3. Does this make sense? Okay. Then we have this together this, this together this. So we now have that F sub 1, which is the next level of vibration, will be equal to what? V over 4L over 3, isn't it? So F sub 1 will equal to what? 3V over 4L. Does that make sense? Okay. I'll go one more step and then you do the rest. Now, I don't know if I should do what is called end correction here. But there's no need. There's no need. The next thing maybe we should do sonometer. The sonometer. So the sonometer bridge is used for, string instruments. So we have this guy. Okay, the next level of vibration, level 3, we still have our closed pipe. The next level of vibration will be this, something like this. Manage it like this. Manage this. Don't worry, the one you see in your exam will be fine. Alright. But it will look something like this, right? So this way we have node and antinode and node. Remember, that song is very important. You understand? Because the time we were creating this thing, we needed a song to back us up. Node and antinode and node and antinode and node and antinode. Okay, you see that this one is different because if we start with a node, we end up with an antinode. So the entire length here is going to be how many wavelengths? How many quarters? 1, 2, 3, 4, 5. 5 quarters. I'll just say 5 quarter. Does that make sense? so that lambda will be equal to 4L over 5, if that's the case. So that now F2 in this case, yeah, F2 is going to be equal to V over 4L over 5. So F sub 2 will be equal to 5V over 4L. With this, we should be able to create our set of harmonics and overtones. So what's the first harmonic, second harmonic, third harmonic? That's what we did. First harmonic is what? V over 4L. Second harmonic is what? 3V over 4L. Fourth harmonic is what? 5V over 4L. What do you notice? I am noticing something that this guy, our next guy now, these guys are odd number integers. Odd number integer multiple of the fundamental frequency. Because here is 1F0. Here is 3F0. 3 times this. The next case is 5F0. What will be the next harmonic? 7F0. This is simple, right? All right. So that is it for harmonics and overtones. So if you have gotten the concept, then you can click out of the video. But I still want to show you something. So if you're interested, stick with me. All right. We have sonometer. The sonometer. There's a song for that one too. It goes like this. Somebody says sonometer. Sonometer. All right. So we have the sonometer. Now the sonometer is a particular, when you hear sono, you know I've told you before, whenever you hear the word sono, it means sound, right? It refers to sound. The meter, measure, right? Okay, so we use it to measure vibration produced on a string that is of known length. Is that okay? So now, it is discovered from, this is experimentally, it is discovered that the frequency of sound in a sonometer is directly proportional to the square root of the tension in the string. That same frequency is inversely proportional, however, to the square root of the mass per unit length. Is that okay? Capital M. You see, it's not small m, so it's not mass. It's the mass per unit length. Then the frequency again, that same guy, is inversely proportional again to the length of the string. So by the time we combine all of these properties, we are going to have F will be equal to 1K over, there's a constant of proportionality, right? K over L root T over root M, capital M. And I say capital M, this one is confusing. So capital M is mass per unit length. Now, if you are given the mass, just divide by the length you are given. That will be your capital M. Do you understand now? That is mass over L. M capital is equal to small m over L. All right. So in this case, F therefore will be equal to K over L root M root T over M. Now, this K is dependent on the mode of vibration. The K is dependent on what? So if you are in the fundamental mode of vibration, if you are in the keep in mind, because what confuses students, they will say they use the right formula, but they did not get the answer correctly. So this only works for higher frequencies. Is that okay? But for the fundamental mode of frequency, K is actually 1 over 2. Do you understand? So if that's the case, then K will be equal to, so F sub naught will be equal to what? 1 over 2L root T over M. Does this make sense to you? So this is how you apply the formula. So that will be it for this video. Do want to subscribe to the channel. I'm going to link the video in the description where I mentioned everything, discuss everything you need to know about sound waves. God bless you as you subscribe and share the video. See you. And don't forget the song. No, Dan, Nancy, no, Dan, no, Dan.